Hi everyone, I'll be discussing Leetcode 1664 problem ways to make a fair array. So in this problem we are given input integer array nums and we can choose exactly one index and remove the element. An array is fair if the sum of odd indexed values is equal to the sum of even indexed values, and we have to return the number of indices that we could choose such that after the removal nums is fair. So let's discuss what the problem statement is trying to convey. So for example, in this case 2164, if we remove 2, which is index 0, we would be left with 164. Now here uh, the there is 0 indexing, which means that 0, 1, 2 would be the indexes. Now even index is 0 and 2 and odd index is 1. So sum of even index is 5. So sum of even is 5 and sum of odd is 6. Both these both values are not equal. So if we remove 2, we would not get this fair array condition. Now if we remove this 1, we would be left with 2, 6, 4. Now here sum of even is 2 plus 4, which is 6, and sum of odd is also 6. This is fair. This is not. So we have found one index for which the array would be fair. Now if we remove 6, the array would be 2, 1, 4, and sum of even would be 6, sum of odd would be 1, not equal. And if we remove this 4, we would be left with 2, 1, 6. Sum of even would be 8, and sum of odd would be 1. It's also not equal. So only for index 1 we got fair array, so which means that we would return 1. Only for one index we got this fair array thing, so we would return this count, which is 1. So one way to approach this problem is to basically apply the brute force approach, which means that we would basically be um, removing this 2 index. So when we remove this 2 index, we would be left with 164, and we would loop through this array and count the odd index and even index sum. We would do the same thing for this also, and this also, and this also. Now when if we look at the time complexity of this brute force solution, it would be O of n square, because when we remove this 2, basically we are removing n elements, because first we are removing 2, then for after removing 2, we are looping n times. N basically here means the length of this nums array. It would be n minus 1. So and then we remove 1, so it would be again n minus 1, again n minus 1, so on till n minus 1, and this would happen for n indexes. So the total would be n minus 1 plus n minus 1 plus n minus 1. This would be the total time, and this is n times. So total time complexity would be n into n minus 1, which is also order of n square only. So the brute force approach here would um, not be the optimal solution to this problem. So a better approach to solve this problem is to use prefix um, prefix sum array for both even index and odd index. So what I let's say if the input is this 2164. Now I would create even some input, um, one array which is, let's say, even some, which would basically have sum of all the elements, all the even indexed elements, and odd sum would have sum of all the odd index elements. So this is currently 0, 1, 2, 3. Now 0 is an even index element, so we would put 2 here. So basically, and 0 here. So the sum, basically the sum of even indexed elements till index 0 is 2, and sum of odd indexed elements till index 0 is 0. Now here also we would put 2 only because this is an odd index, and this one would be added here. Now this 6 would be added to this previous 2, which would give 8, and this one would be carried on from this previous index. Similarly, this 3 is an odd index, so this 8 would basically be carried forward from this index, and this 4 would be added to this one because it is an odd index. Now these are the two arrays. Now there are three conditions if we are removing 0th index element. So if we are removing 0th index element, then basically we would look what is the odd index sum and even index sum. So if we look at these two arrays, now when we remove this 2, we would be left with 164. Now if we see, basically the odd sum would basically be, since we are removing an even index element, all these odd index element would be shifted to even index, and all the even index elements would be shifted to odd index elements. From that, what I am trying to convey is that, let's say initially it is 2164 and this is 0, 1, 2, 3. Now when we remove this 2, we would be left with 164, which is 0, 1, 2 here. Now this 1, which is odd index, is now even index. This 6, which is even index, is now odd index. This 4, which is odd index, is now even index. So now odd sum would simply be obtained from this even sum only. So we would look what is the even sum at the final index. So even sum is 8, which is 8, and since we are removing this 0th element, so we would subtract this, and we would obtain odd sum as 6, which is also true because if we look at this array, odd sum is only 6. Now if we want even sum, it would simply be um, this odd sum last index only, which is 5, because and if you also see from this 164 array, this 1 plus 4 is 5. So, and this is the even index. Now the second condition is that if I equals to n minus 1, where n is length of nums. So in that case, what we would basically say is that, if if the array is, whether the array is, whether the last index of the array is even or odd. Now if last index is even, if last index is even, then basically what that means is that here it is odd, so let's discuss that only. So if it is odd, now last index is odd, which means that even sum would simply be this 8 only, because last index is odd, which means that um, odd sum, which is 5, would be subtracted by this 5 would be subtracted by this last element index, which is 1. So in the other case it would have been even equals to sum of at the last index minus whichever the number is present in the last index, and odd sum would have been same at as the odd at last index only. So these are the two conditions, and the third case is when none of these two cases are true, which means that if there is present in between, basically not in the endpoint. So in those cases, basically, so for all the other cases, so let's say if in this else condition, if the array would have been 2164 and we would want to delete this 6. Now if we see we have 2 1, we would be left with 214. Now if you see this 0 1 2 3, now here this 0 is at 0 index here only, and this one is at 1 index only, but this 4, which is an odd index, is now converted to even index because a element before it was removed. So all the elements after this removed element would basically all the odd sum and even sum would be swapped after this deleted element only. So now here even sum would be this basically if we are removing this second index, we would see what is the even sum before this, which is 2. We would keep it because that remain intact only, and after that we would see what is the odd sum, total odd sum, which is 5, and we would subtract um, what is the sum um, before this element, which has to be included in odd sum and shouldn't be included in even sum. So which is 1 here, obtained this obtained before this index, which is 2, an index before it is 1, and the sum odd sum here is 1. So this has been removed from this odd sum, and we will be left with 6. And for odd sum, um, we would have 1 plus 8 minus, here instead of removing this 2, we would want to remove this 6 also. This second because we are removing the second index also, so we would want to remove the sum corresponding to it also. So we would remove 8 minus 8, which is 1 only, and which is true also if we see the even sum is 2 plus 4 and odd sum is only 1. So this is the explanation to this whole code, which is written over here. Um, The time complexity of this solution is simply O of n, and space complexity is also O of n because I am using this prefix even sum and odd sum arrays.